Hello everyone, this is Muthukrishna here. In today's session, I'm going to teach you guys how to improve your project performance through optimization and best practices. So before getting started, we need to first understand why should we optimize, right? So at the time of project creation itself, you would have decided what your target platform and what should be the quality level of quality, right? So whether it is a desktop or mobile or maximum scalable. So how did you decide upon it? Simply your target audience, right? So usually how things works, when the client comes with their requirement, we try to understand their requirement, we try to understand who their target audience are, okay, on which platform does this particular application is going to run on. So the target platform's length and breadth, the resources available, the CPU power, the GPU power. So based on these limitations, you try to fix on the target platform and the quality level, right? So this is a sample scene that I have taken for the demonstration. It's a scene on which my colleague is working on. So he finds it to be a little bit lagging, and I am trying to improve the performance. Okay, so how do we do it? So we need some data, right? So uh, let me simply turn on the frame rate. So also you can just go to your editor preferences, search for frame rate, and at the top you can get the same data. Okay, so here we have two. So one is the frames per second and the other is the frame time. So both are same, like where I hope you guys know how to calculate it, right? So you just divide per second with the frame time, you get the FPS. So my goal is to bring down the frame time. So when we talk about the performance, we always focus on the FPS, right? So what happens? So how do we bring it down? If I'm targeting, like say, a 30 FPS experience out of this scene, so I need to bring it down to 33.3 millisecond for a frame. Or if I am planning for a 60 FPS experience, then I need to bring it down to 16.67. And if it is going to be 120 FPS experience, in that case I need to bring it down to 8.33 milliseconds. So it is really challenging task. It is like, so what is happening actually, for every frame the CPU and GPU has to calculate everything, including the lights, the polygons within this scene, and if there are any blueprints or any C++ logic. So everything needs to be calculated by the CPU and the GPU, right? So that is why, so in this particular case, so you can find at some places they are okay, and some places there is a drop in the frame rate, right? Okay. So before starting to optimize, what should be done first? So we need to know where to start with, right? So in order to find the starting point for optimization, we need to have some data, right? So data means what? Like where your So what is causing the bottleneck, or what is causing the frame rate to drop? Okay. So how do we do it? How do we get the data? So there are some profiling techniques within Unreal Engine. So you can use GPU visualizer. So you can use the GPU visualizer. You can use Unreal Engine Insights, and so you can use the Unreal Engine Insights. You can use the some console commands. So like so where you get to see more detailed information. In our case, so we see three parameters are a little bit needs attention. Our frame rate, frame time, our draw time, the GPU time. So now we have got some data to begin with, right? So usually before optimizing the project, so I follow few steps. It's very easy to follow. Like by logic, we need to first identify the problem and the root cause, which is the root cause of the problem, and you need to find, okay, what type of solution that you can apply, and then you find some the outcome, whether the solution that you have applied has brought in any impact or not, and then you redo the process. Okay, the same logic, that is what we are going to apply for the optimization process also. So we, in our case, we are seeing there is a drop in the frame time, draw time, like a higher frame time, higher draw time, higher GPU time, right? So these are very critical for the project performance. So that is where we are going to focus on to improve the overall performance of our project. And here you can find the game time to be in green color. The reason being is that within this scene there are no blueprints or any logics that are running currently. So that's why the time taken is it is very less. Okay. So as I said before, yeah. So three steps. First, you identify the issue through profiling techniques within Unreal Engine. We have seen you can use the GPU visualizer, you can use the Unreal Insights, you can use the console commands to get the data, so where the problem is. And then step 2, you need to apply the solution. So I usually apply one solution at a time. I find any change, whether the solution has brought in any change, it has impacted the performance, and if it is right, okay, then I profile again, I get the data again, and I get to see whether the same issue exists, or any new any other factor is contributing for the performance drop. So I do this process again and again until I get a well optimized project. Okay. So apart from profiling, finding the bottlenecks, solving them, repeating it again and again, there is also something as best practices, which can greatly improve the overall project performance. Okay. Small things can contribute for a big change. So that's how the best practices works. Something for the best examples could be like, say, here you can find the draw time is high, so which represents the number of draw calls, too many draw calls, right? So how do we do it? So we need to reduce, okay, the amount of draw calls being done. So we'll be looking into some of the best practices in the later part of this session to enhance the overall performance. It is not always the profiling, it is both. You need to do the profiling as well as you need to follow some best practices to achieve the maximum performance out of your project. Okay, so apart from console commands like stat unit graph, you can also use stat streaming, stat RHI, stat memory. So if I put stat RHI, so this will give you GPU related statistics, rendering statistics. So you can particularly you can see, so how many triangles is being drawn, how many draw calls is happening, and the memory allocation to the GPU. So at a low level, you get the low level data. Let me put it back, and if I put like stat memory, so I get to see the overall engine's memory usage, including the total memory, object counts, memory used by textures, meshes, audio. So it is useful for tracking RAM usage particularly and finding if there are any memory leaks. And if I put like streaming, so here you can find, so we are getting a warning over here, right? Texture streaming pool or 100, it is above the budget. So here you can see, so we have allocated so around 600 MB is being allocated for the streaming. So you can increase the limit. So currently we are using a 3060 card, RTX card. So there should be enough memory. So this particularly gives you data about the streaming activity. So like the whether what type of textures or meshes or levels are loading, unloading. So it is useful, particularly useful to have an insight into the texture. So we can increase this memory pool. So you can put like r dot streaming pool size, like say 4000. Okay, so that. So in this way we can get to have the overall idea of where the resource is allocated, a top view of the overall thing. But when you want to dig deeper and understand, okay, what is happening behind every frame, how much, why every frame is taking this much time, like say 50 millisecond. So if you want to understand in depth for each and every frame, as we said before, let me put like unit. So as I said before, when we move around this scene, you can find the frame time is keeping on changing, the draw thread, the GPU time, right? So it is different at different parts of this scene. some places it is okay, some places we are getting red, right? So if you want to understand what is causing it to spike or what is causing it to increase on a frame by frame basis, so this is where we need to use Unreal Engine Insights. Okay, so for the demonstration of Unreal Engine Insights, let me just switch to another project. So the project is loaded. Yeah, so this is where you get to see all the Unreal Insights and its related settings options. So this area, the channel gives you an option of flexibility to choose what type of data you want to track on a frame by frame basis. So by default, the options selected here are the default options. I didn't change anything. So this will give you in particular the GPU, frame, CPU, and if you are doing any bookmark or then so we have log, if you are taking any screenshot, so all this data will be captured. So here you can see for taking a screenshot you can use Control plus F9, or if you want to make a bookmark during the trace you can select over here. Also you can just click on this to take a snapshot, and if you want to bookmark you need to come over here and you need to select bookmark. And so once the trace is done, so there are two options where to store. So it is like trace, store and file. So trace store, what it does is like you put all the traces of different projects at one place, while the file gives you it stores where your project location is. So this will help you in like say selectively storing your traces. And moreover, let me make a note, even few seconds of traces will generate a lot of memory size to file, so you need to keep clearing those traced files from time to time. So this will help you in memorying your disk space, else a lot of space can pile up, will be occupied by the trace files itself. Okay, so you can start the tracing. Once you do the tracing you get to get the raw data and you can investigate one by one. You can go over here start trace, or you can just simply click on this button to start the trace, and once you want to stop you can click again to stop the trace. So and once the trace is done you can just simply click on this open trace directory. So this will take you where the traces are stored, and again so this will take you to, as I said before, the project specific location where you can store like as a, so the difference. So the first one, if you are using the trace store, it stores at this directory, and if you are going with file, so this will store in the project specific directory. Okay, yeah, so we'll start tracing now. You can just click on this trace, and then let me just play. Click on this editor, play in editor button. So let me just move around this scene, this ship. Okay, so I have done tracing, so let me stop. So once the trace is done, you can simply go over here. You can click on Unreal Engine inside session browser. A pop-up window will be shown. So here you can see the date format of the taste session. So and then you can see which platform the trace is done. So here you can see it is the Unreal Engine editor and it is of the development build type. We have run it in the editor and currently we are using Unreal Engine 5.5. So in this way you can get to see, like if you are running different engine versions, and we can simply identify okay which engine version is being used. And also we need to make a note that okay the tracing file takes up a huge amount of memory, so we need to make sure okay we clear time to time if there are any older files which are not necessary. So currently in total of 9 traces is being done, and it consumes around like say 460 MB. Also you can open the same file. You can just go to recent traces and you can just click on the file. So you will get a pop-up window. So into the insights browser. So at the top you can find this is the total traced of the frame time. So there are some spikes in between. So there is one place where it took a lot of time for calculating, and on the right side you can find the parameter which is the marking. So below this line or so those bars which reach to this particular line, it means like we are getting a 60 fps at these places, 60, 70, and those bars which are reaching up to here we are having a 30 fps, and here we get 20, 15 and so on. So we need to make sure okay we get less spikes, lower the spikes, we have better frame rate or lesser time for rendering the frame. So when we click on a particular spike, so I can just scroll in. So I get to see the data of it. I get to see the highlight of that particular frame. I can simply scroll. So on the left you can see, so there is game thread, RHI thread, render thread. So these are the very important parameter that you need to look into. So when it comes to digging deeper into the frame time, so the game thread, so this is where you see for this particular frame it has taken a 50.6 millisecond, while the RHI thread has taken 46 millisecond and the render thread has taken around 51.9. When you click on the game thread, so this will give you what is causing this frame to take 50.6 millisecond. So here you get to see the hierarchy or hierarchical view of that task or the callee, and you have the caller. So basically what happens is the game thread decides what to render and your render thread decides how to render it, while the RHI thread decides when to render it. Okay, so that's a very gist you need to understand, and you get to click on each to see so why, so where the time is taking. Okay, So as I said before, the game thread, so it is waiting for something. So if I just go to some other frame or something, this particular frame, see, so here the GPU, so this is taking around 35.59. For lights is taking 26.3 milliseconds. Well, the game thread is taking 120. This is huge. So 120 millisecond is really huge. And I'll check some other example. Okay. So each frame you can see the parameters are changing, right? So if we take some other lesser frame time, so here for the widget it is taking some time. If I click on some other frame, so for each frame it is different, it is not the same. So you can't come to a particular conclusion, okay, only one parameter is causing the spike. So you need to investigate frame by frame, and then only you can get to have an idea. Okay, so we have automation view modes, which can also help you in enhancing your game performance, your project performance. So to switch to the automation view mode, you can just go to the view mode, automation view mode, and you can switch between the different view modes to better optimize. So the light complexity view mode gives you an idea of how much complex the light is in your scene, while the light map density gives you an idea of, okay, so what is the light map resolution that you are using in your scene. And we have the stationary light overlap. It gives you an idea of whether the lights are overlapping, and the shader complexity gives you whether uh, the shaders used in the scene is complex or not. And the shader complex also give you a similar idea. The quad overview, okay, whether any translucency objects are overlapping too much and so on. And the texture streaming accuracy, so this will, each view mode gives you an idea of like whether you are using the right textures, their UV density, scale of the texture and so on. So we'll look into one by one. We'll first go with the light complexity. So here you can see at the bottom there is a bar. So this is a graph to give you an idea of whether there are too many lights overlapping. If they are overlapping, in that case it will be extremely white, and on the left side it says something blue or dark black, or black something near to black. It means they're good, but basically when you use lights, okay, they do overlap, right, sometimes. Okay, let me go to the outliner. Here we can see, we can filter out the lights that we have. We have some point lights in our scene, so you can see, so all these point lights, okay, they are overlapping too much. Let's say the whole area is white, the total ship is white. You can see the attenuation radius is spanning over very large area. So let me select one. This particular light is, let's say, okay, at the bottom of the ship. I don't know like how far this light will be looked into. Okay, we'll switch to some other light. Okay. So this is one light which is at the center is actually affecting a very large area, the total ship itself. mm. And if we go with one by one, oh my god. So this light is here, but it is covering a very large area, right? So if we just go to the details panel, their attenuation radius is too much. So what I'll do, I'll first bring down the attenuation radius to say 200 first. Okay, so we have brought the overall. Now you can see there is a big change from extremely bad to good, somewhere good, but still, but this is not what we wanted, right? We want to have a well lit but a balanced light within our scene. So what we can do, we can consider those lights which are at the center, so which can cover a considerable distance. We'll increase it like say 700. I think this should be okay. And similarly we'll have one light per area to cover a decent amount of space. So okay, and if I go to my view mode, I think this is okay, not bad when compared to before. Also I can increase these lights attenuation radius, we like say 350. 350 to have better lit at these places. I think this should be okay. See, we have increased the frame rate to 52. Earlier it was like say some around so we had 26, right? So if we redo, so now from 26 to 50, 50, 56, 60 is really great. So there is some error. What error? Okay. Right. When we try to play, okay, so there is some collision within this scene, so which is blocking our movement. Okay, so we can just go to collision. So this will give you an idea of okay, what is the collision within your scene. So some of the collision is covering a very large space which is not needed. for the time being. So we'll select the collision. So you can either change the collision property here, or you can just simply go to the mesh editor. If you find all the instance needs to be changed, so we'll keep it like no collision as of now, or you need to look into the collision. So this is really huge. So you can simply remove the collision, you can add a capsule, and you can reduce the radius of the collision, like say 20. So we'll reset. Okay, since the pivot is somewhere else, so we need to do it manually in that case. So we'll just go to the top view, increase the size like 50, 100, 200, 150. So should be okay, and we'll increase the size. This should be okay. We'll save. Now what happens, we have the collision for the pole alone. Similar way, we have collision for this. So what we'll do, we'll simply make it no collision as of now. There is another one. So we'll make it no collision. Okay. So if we try to move around now it is possible. Okay, so that was a very huge collision actually. Fine. So we are hitting a 60 fps, right? Then we'll go to light map density view mode. So it's the other view mode. So here you can find the UV density, light map UV density is different for different objects. So wherever you see the green is good, while the red is bad, which means red means it has a very high density which needs to be reduced, while a blue is less dense, you need to increase. So let me just change for those objects which are red in color first. So let me just put like light. So it says it has a value of 256. So we'll clear the filter. We'll select all the crates. So we'll bring it down to 64. So now it has turned to green. In similar way, so there is beef. we'll bring down the beef value to like say 16. So cheese, so we'll bring it down to like say 16. So we have broken egg to like say 16. So we have canons. So we select all the cannonballs and bring it down to like say 16. So the barrels, we have few barrels, we'll bring down the barrel value to like 16. So now you can see, if I go back to my, so we have a decent like say 66, a decent amount of frame rate has increased, and during runtime I am getting around like say 80-90 fps. So there are some more objects that needs to be changed. So next we will go to shader complexity. As I said before, these objects which are in green, it means the shaders are simple, easy to calculate, while you can see we have glass bottle, right? So they're translucent in nature. We can see there is water shader. So objects which are translucent in nature are highly complex, so that's why we have those in terms of like say pink to white. So they're okay. Next is we can go to the quad odra. So here, same as before, these glass bottles you can find they're translucent in nature also, like where you can have an overlapping. So the bottle, like say it is hollow in nature, right? So it's overlapping and it is quite complex. So so there is a high amount of odor here. You can see the color coding. It says okay. When compared to the other objects in the scene, green is a little bit having a higher odor. Red is even more, much more. So these are the places which will bring in cost to your hardware. And then we can go to the so here the required texture resolution. So this will give you a better understanding of your scene texture. So in our case, let me select this watermelon, and if I just select its normal map, okay, so here from this distance, okay, it says okay, the texture is somewhere okay, between good and little bit extra. So this part of the optimization vmodes will give you an idea of whether you are using the right size of the textures, the distance, the UV densities, and so on. So if I just move towards the watermelon, you can see from this distance the texture used is somewhere okay, less in detail. While if I am looking the same object from this far, it says it is good to little bit extra. Okay, so this will help you in understanding, like say if you are trying to place the objects in a scene which is far away from the user reach, and which doesn't require a higher resolution texture. So if I see from this far, it says a little bit extra. Mm, if I select the stairs and see, so it says this particular object is using a texture of higher resolution from this distance. So in game, if the player doesn't reaches this space, so where it is somewhere in the mid ground or in the background, so it doesn't require a texture of this size, so you need to bring it down. So how do we check it? So you can just look over here. So this will give you where the texture is, and if you open it up, so it is actually using a 4K texture, right? So the imported size is of 4K, the displaying size is of 4K, which is huge actually. So when it comes to a game experience, 4K textures should be avoided. So you need to go with a 1K texture at most. It depends. Okay, if the player character is going near the object and a lot of details is required, in that case you can consider. But in this particular case, I don't think so. So actually, you can just use tools, audit, statistics. So here you can see this gives you an idea of overall objects in your scene, the number of instances of the object, and the triangle count and the size and so on. And coming to the texture, so this will give you an idea of okay, what are the textures used in your scene and their current dimension. So here you can see pirate letter, it is using 4K texture by default. Okay, while some are using a lower texture sizes. So you can use and sort it in order. A lot of 4K textures are being used in this scene, so which needs to be looked into. And there are some textures which are not in the power of 2, so these we need to consider, okay, because they take up too much of memory. Because if they are not in the power of 2, like say if we put it over here, so when you import the asset into your project, so the textures are imported, right? So what Unreal Engine does is it generates map maps for the texture. Okay, only and only if you are having the texture in the power of 2, it can generate the map maps. Okay, and you can also like reduce the texture size, like say if there is like 4K and if you want to bring it down to like say 1K, you can simply put like maximum texture size to be 1K. So what happens, even though you have imported as 4K, the maximum size that that is allowed in game to be 1K. So in this way you can just reduce those texture sizes which you find it to be huge, unnecessary. So far we have seen how to find the bottlenecks in your project, and we have also seen how to use the automation view modes, and now we'll look into the best practices that can help you in improvising the overall project performance. So to begin with, let me just go to the project settings. So in particular, we need to focus on the rendering settings, because this is where the settings which will greatly affect your overall project performance itself. Okay, if I just go with the collapsed view, so from mobile settings to material settings, textures, virtual textures, runtime virtual textures, global illumination, reflection, direct lighting, hardware ray tracing, software ray tracing, nanite. See, all these settings are very key to your project itself. In particular, when you are dealing with VR or mobile, so we have also the VR setting, right? So each and every setting, like when it comes to the shading method, uh, so whether it is FA, TA, MSA, so for low end we go with forward shading, while we are focusing on quality we go with the deferred shading. So this gives you sometimes this fast approximate is the fastest of these, can give you some blurry images sometimes, while MSA is a balanced one. If you are looking for quality, TAA is the one. So each and every category has some of the key settings that will greatly affect the project itself. Global illumination, whether you are going for lumen dynamic lighting, and the ray tracing mode, surface, cache, and whether you are going for hardware ray tracing or only the software ray tracing. If you are having RTX card, in my case I have a RTX card, so I can go with the hardware ray tracing. So people who don't have a strong GPU, you can just go with the software ray tracing for better results. Runtime virtual textures, so we have virtual textures, runtime virtual textures. These will greatly help you in enhancing the overall performance of your project itself. So how it works is like while streaming large textures, it is really it will really bring down your performance itself. While the virtual textures, what happens, only a part of the total texture is getting streamed, so it greatly boosts your performance itself. Okay, and reflections, yes, we have whether how the reflection should happen, refraction, translucency. Okay, so most of the main settings, so in any balance of these can either give you a good quality with offsetting the performance, or you can get the better performance offsetting the quality. So you need to make sure, okay, what type of setting you want to choose for the right quality and performance. Okay, so you need to have a better deep understanding of these settings. So after the project settings, so we need to focus on the draw calls. So what makes the a higher draw call? So if I just put stat unit, so you can find it is taking around like say 50 to milliseconds, right? So how can we reduce it? So in our scene there are too many objects filled, but they are repetitive, right? So how can we reduce it? So if I look over here, my outliner, I have too many barrels put together, right? I can simply convert them into, just go to the modeling mode. I can, instead of using meshes, I can use instance static meshes. So I can convert them in this manner. So now what happens? So these have been converted into instance static mesh. If you just go to the details panel and if I just select, here you can find earlier we had many meshes of similar type. Now it has been reduced. Similar way, so we can convert these cannonballs. So we have too many. So if I just select, okay, and if I harvest them, so you can see the okay, we have crates and we can harvest them too. So we have ropes. I think these are different. So okay, from here to here, okay, we have different rope meshes. Okay, and we'll harvest them. So we have circle ropes and so all these are same. So we'll try to convert. So we have wooden beams. We have n number of wooden beams. Is keeping on going, and we'll harvest them. Okay, So we have pirate board. And we harvest them too. So we have stairs. We have ropes. We will harvest them too. So we have these many chests, and we'll harvest them too. So considerably, I think we have brought down the draw time little by little. So there are a lot more to do. So in this way you can convert all your measures into instant measures if there are too many which are repetitive in nature. So there is another method of creating instance measures. So here you can see there are like say 12 canons, right? So you can just select them, right click. So here you can see level. So the first thing is like create level instance. So a level instance will be created, so where these actors will be within that level. And the next one is create packed level actor. So this will create two assets. One is the level and other is a blueprint actor. So within the blueprint actor you can get to see uh, the instances of the mesh. So if I just open the blueprint, so here when I select it, so there you can see the static mesh, and at the bottom you can find the how many instances of the meshes and their location where they are. Okay. So the next thing that you need to focus on is the use of LODs for a static mesh. So when you open your mesh editor, you can find on the right in the details panel, so the number of LODs for this particular object is just one. So what happens is, irrespective of where this object is within this scene, it will only have one level of detail, so where the maximum triangles is being loaded, right? So if I am just putting it like say 8 number of LODs, and if I just apply the changes, now what happens, so at this particular distance I have LOD 1. If I zoom in, I get LOD 2. So you can see there is a significantly drop in the number of triangles, right? So in this way, if you have meshes that without the LOD, so you can generate the LODs. Also you can also have a control over so you can have a control over the reduction of the triangles. Suppose if you want the LOD to have 50% of what it is already. So you can just apply change. So the final thing that I want to cover is the texture optimization. So as I said before, so try to use a lower resolution texture when you are trying to build games. So here you can see a 2K texture. So always use a texture which has a power of 2, so that Unreal Engine can create a maps. So for this particular texture we have a level of 12, a total of 12 instance of the map is generated. So from level 0 to level 11. So level 0 is of highest quality, and if we go with a number lower, so here you can find, so the display is 2 by 2, this is 128 by 128, so 512 by 512. So every increase in level, the half the size. Okay, so try to use a power of 2 maps, textures particularly, and also try to utilize the optimization view mode, the required texture resolution, to get to see so which size of texture is optimal for your scene at a particular distance. Okay, thank you.